Hi, Assalamualaikum. My name is Nur Shamira binti Sabri and my matrix number is 2022 748 227.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amalia Aisyah binti Ahmad Nizam and my student ID is 2022 765 395.
Hello and hi, my name is Siti Nur Aisa binti Muhammad Siddiq. Okay, my student ID number is 2022736629.
Hi and good day everyone. I'm Nur Anis Atira binti Rizwan. My student ID is 2022750683.
Hi, my name is Nur Afika binti Abdul Kadir with student ID 2022765567.
Hello everyone, today we will learn about subject Educational Statistics 2. Okay, in this subject we will learn one topic in estimation of parameter which is chapter 3. In this chapter we will cover subtopic 3.2.4 which is confidence interval for two population means. Because the figure is based on a sample of the population you are investigating, there is always uncertainty when you generate an estimate in statistics, whether it be a summary statistic or a test statistic. Okay, the confidence interval is the range of a value that if you repeated your experiment or resample the population in the same manner, you would anticipate your estimate to fall within a specific proportion of a time. The alpha value determines the confidence level, which is the proportion of time you anticipate being able to recreate an estimate between the top and lower boundaries of the confidence interval. To estimate the difference in population means using two sample and test statistic, you will literally learn about confidence interval for different two population means in today's lessons. Well, there are three cases in confidence interval that we will learn. Okay, the first case is where the two variants are known. Second is the variance are known and the variance 1 is equal to variance 2. And lastly is where the variance 1 is not equal to variance 2 and the variance is unknown. First, let's start our lesson today with case 1. Before start, let me tell you what exactly is a confidence interval. The mean of your estimate plus and the minus the range of that estimate constitute a confidence interval. Within a specific level of confidence, this is the range of value you can anticipate your estimate to fall within if you repeat the test. In statistics, confidence is another word for a probability. If you create a confidence interval, for instance, with a 95% level of confidence, you can be sure that 95 out of 100 times the estimate will fall between the upper and the lower value indicated by the confidence interval. Typically, the acceptable level of confidence is 1 minus the alpha value that you use in your statistical test. Level of confidence equal to 1 minus alpha. For example, if the value of alpha is used of population less than 0.05 for statistic significant, then the confidence level would be 1 minus 0.05 equal to 0.95, or we call it as 95%. So for the case 1, the data suppose come for the two normal population with mean 1 and mean 2, and the two population variance are known, then alpha 100 multiplied by 1 minus alpha value, confidence interval for the difference in the population means mean 1 minus mean 2. Okay, therefore the formula would be sample mean minus sample mean 1 minus sample mean 2 plus minus value of the z alpha divided by 2 multiplied by the square root of variance 1 divided by the n1 plus variance 2 divided by n2. Let's see and try to solve the example of the question below. The question says, a survey that the average hotel room rate in Setia Alam is RM100 and the average hotel room rate in Puncak Alam is RM80. These data were obtained from the two samples of 50 hotels each. Suppose that the population standard deviation were known to be RM10 and RM7 respectively. Assuming that the data are normally distributed, construct a 95% confidence interval of the true difference in your means. Okay, from that question, we know that the value of the sample random means 1 is 100 and sample random means 2 is 80. Alpha is 5%, which is 0.05. And we know that variance 1 equal to 10 and variance 2 equal to 7 and n1 equal to n2 and equal to 50. Okay, insert all the value in the formula, and for the z value, you can refer to the table 4, which is a percentage point of the normal distribution. So, after calculate all that, the final answer would be 16.6164, 23.3835. So that's all.
I will explain the type 1 of second cases in this topic, and I will show one example on how and when you can apply this formula. The condition to apply this formula is when the sample size is equal and more than 30. ST in this formula also we call pooled sample variance. The table before is a summary of data with sample size 3,534 participants attending the 7th examination of the offspring cohort in the Framingham Heart Study. From the data before, calculate the mean difference in systolic blood pressure between men and women and find a 95% confidence interval for the mean difference. The sample is large, which is greater than 30 for both men and women. Assume that the population variance is equal. Step 1. Find the point estimate, which is you need to subtract the means 128.2 minus 126.5, and in this case, the answer will be 1.7. Step 2. Find the z-score. 95% confidence interval is equal to 0.95. So, to find alpha, 1 minus 0.95 and we're gonna get 0.005. From the value, we need to divide by 2. After that, find the z-score using the table percentage points of the normal distribution. Now, we are going to find the margin of error. We are going to take the z-score 1.9600, which we found on the previous slide. We are going to take the first n value minus 1. So, 1623 minus 1, which is equal 1622. We're going to take the corresponding standard deviation and square it. Then we are going to take that added with 1911 minus 1 times the second standard deviation squared, and then divide it by 1623 plus 1911 minus 2 will equal to 3532, and then we are going to take that times the square root of 1 over 1623 plus 1 over 1911. Those values coming from the sample size. We find the margin error to be 1.2538. Step 4, we are going to subtract that from 1.7, which was our point estimate, and then add it to that. The final answer will be 0.446 and 2.954. Calculate using Excel. First, to find N1 plus N2 minus 2, you just need to click this cell and then type equal, click the N1 value and then plus N2 value minus 2, enter. You will get the answer. To find the point estimate, you just click the cell, type equal, click this mean 1 minus mean 2. Click enter. Then, to calculate the standard error, click this cell, type equal, square root, bracket 3 times, click this N1 value, minus 1, close bracket, times standard deviation 1, square, plus, open bracket, and 2 minus 1, close bracket, times standard deviation 2, power of 2, close bracket, divided by this one, close bracket, and times square root, open bracket, 1 divided by N1 plus 1 over N2, close bracket, and enter. You will get this value. Next, to find the critical error, you need to type equal t.inv and double click this. After that, type 1 minus C level and click this value. Close bracket, enter. You get the C score. To find the margin error, you just need to click this cell, type equal, click critical error, times with standard error, enter. Next, for the lower limit, you need to type equal, click point estimate, minus with margin of error, enter. After that, for the upper limit, just change with plus symbol, click equal, estimate, point estimate, plus margin error, enter.
Next, case 2 with second condition which N1 and N2 less than 13. For this case, we will use this formula that uses T distribution. So, let's look at some examples. In example 1, it said that last semester, male student had outperformed female student on statistic test given at a college. The statistic test score obtained from a random sample of male and female students and is shown below. Assume that the population variance are equal. The data collected was analyzed and output is shown below. So, the question wants us to construct a 99% confidence interval for the average statistic scores of female students. So, to know this question is case 2 with second condition, we see from the question given. It says that population variance are equal, but it does not give the value of population variance. So, population variance is unknown. After that, look at the sample size. For males and females, it's less than 13. So all the information we have, we can consider this question is case 2 with second condition. So we can continue to answer the question. Step 1. Find the t-value. From the question, it wants us to construct a 99% confidence interval. So A equal to 1 minus 0.99, then we get 0.01. So we substitute in the t distribution formula and we get t 0.005 and 26. To find the value of t, we will use this table to find the t value and we get 2.779. Next, step 2. Find the pool sample standard deviation. Use this formula for SP and substitute all the information we get in the question. And we get the answer for pool standard deviation is 7.1568. And the last step, we need to substitute all the information we get in this formula. And the answer is negative 7.0872 and 7.9472. Next, to further understanding, let me see example 2. It said that the following are the scores obtained in the English assessment test by samples of 9 boys and 10 girls. All the boys and girls are the same age. So, these test scores of boys and girls. Assume that the data are taken from two normally distributed populations with equal variance. Construct a 99% confidence interval for the actual difference between the average test score of the boys and girls. So, it was stated in this question that populations are normally distributed with equal variance and the number of samples is less than 13. So, we can use case 2 with the second condition. So, let's continue to answer the question. Step 1. Find the mean of boys and girls. Because in this question, it's not given, so we need to calculate it ourselves. For boys mean, add all their test score by divided by 9 and we get 105.33. Next, girls mean, add all the girls' test score and divided by 10 and we get 97.1, or you can use calculator to find mean. In this video, I will show you how to find the mean using a calculator. First, you need to turn on your calculator and press the mode button and then click on step, which is 3. Press 3 and then press 1. In this section, you should enter the information from the question. For example, we enter the number of English test scores for boys. So enter the information of a boy, 100 equal 89, 98, 120, 102, 98, 101, 115, and 125. So, if you have already entered all the numbers, click AC. And then press Shift and 1. So, after that, press variance, which is 4. Press 4. And choose 2 for mean. So there is a symbol for mean and then press equal. And you will get the answer for boys mean, which is 105.3333. So for girls mean, you can try by your own. Step 2. Find sample variance using this formula for sample variance. And we get sample variance of 141 for boys and 410.1 for girls. Step 3. Find the pool sample standard deviation. Substitute all the n and variance value and get 16.8364. Step 4. Find t-value. In the question, it's said to construct a 99% confidence interval. So A equals to 1 minus 0.99 and get 0.01. And substitute in the t distribution formula and get t 0.00517. Next, use table to find t-value and we get 2.878. And the last step, substitute all the information we get in this formula. And the answer is negative 14.1883 and 13.6483.
So today, I will show you the example of the confidence interval for difference to population mean. For the first example is, suppose a random example of 16 material of the black scarf and 13 pieces material for the nude scarf were selected. The sample mean for the black scarf is 220, meanwhile the variance for the black scarf is 120. And the sample mean for the material nude is 119 and the variance for the nude scarf is 19. So now, compute 19% on the difference with two population mean. So here I put the formula for the third cases, which is x bar 2 minus x bar 1 minus z alpha over 2 square root variance over n number and plus variance over n. So that the formula for the third cases. So here the step 2 for the example of the number for the black scarf and nude scarf. For number of nude scarf is 30 and for the number of the black scarf is 60. Find the value from the statement and state the important data. So that from the statement, please pick wisely what is the variance, number, sample means, and also the standard deviation. This is the important things. If you are put the wrong number or the wrong variance, you will get the wrong answer, finalized answer. So for the step 3, you need to see the statistical table and find the Z value, which is 0.05 in the statistical table. You need to see wisely where 0.05 in this column for alpha. And I got this 0.05 and I got the Z alpha, which is 1.6449. Just please be alert because the similar decimal just 0.048. Just be alert with the 1 and 2 decimal point. So we move to the next step. For the step 4, we need to insert and calculate the value, which is you need to use the formula that I have given in the second slide. So here I state the formula for you and you need to put the mean, the variance and the number. And for this question, you can get the answer. The first answer is 26.3298 and for the second answer is 33.6711. So this is the solution and the step by step you need to calculate from these cases, which is cases 3. So we move to the next example. So here the second example for these cases, which is greater than 13. Here, the random sample of 500 dictionary and 315 comic were chosen. The sample mean for dictionary is 256, meanwhile 115 means for comic. The standard deviation stand for the dictionary is 9.7, meanwhile 6.5 for comic. the question is you need to construct a 95% of the difference of population. So here you need to use the formula that I have given to you in the earlier slide. But don't worry, I will show you the same formula in this slide. So let's see how the calculation is going on. For the step 2, you need to find the value from the statement and state the important data just like for the first example. For the x bar, in this example is 256 and x bar for the second is 115. So we move to the next step, which is the calculation for this example. For the step 2, for this example, you also need to see the statistical table. Why you need to see the statistical table? This is because all the value of this normal distribution and why we choose the table 4. This is because the table 4 have the alpha of the value, which is 0.05. We have this 1.6449, and from that, the formula for the cases 3, we need to put and insert the Z alpha. So here you need to see wisely again, and you need to put the real number for the alpha. Next, we move to the next calculation. For the step 4, we need to put the value, which is 256 in the number and 152 for the second number, and also have the variance and use the same formula for the cases 3. For this example, we have the final answer, which is 100.531. For the second answer is 111.469. This is because I put the real variance, the real number of means, and I followed the formula that I have given. So that's all from me. We move to the next presenter. Thank you.
Assalamualaikum and hi everyone. I'm Nur Amalia Aisyah and now I will be teaching about the second case in the case 3, which is N1 and 2 is less than 30. I'll be constructing the confidence interval for population mean using the student's T distribution. The confidence interval for a population mean is determined by taking the sample mean, the point estimate, and subtracting and adding a margin of error to it. As seen in what my groupmate said earlier, if we assume the population standard deviation is known, so the margin of error is determined by this formula with a Z critical value. Since the population standard deviation is usually unknown in practice, it is substituted with the sample standard deviation, which requires we use the T distribution. The T distribution is similar to the standard normal distribution in that is also called bell shape, has a mean of 0, and has an area of 1 or 100% under the curve. In constructing the confidence interval for a population mean, given the sample standard deviation, the margin of error is given by this formula, where T alpha over 2 is the critical value, that is the value that we look up in the table or obtain using software with degrees of freedom of n minus 1. S is the sample standard deviation and the N is the sample size. Alpha is the significance level, which is 1 minus the confidence level. So, for a 90% confidence level, alpha will be 0.10 and that is divided equally into two tails. The values corresponding to these boundaries of the confidence interval are the critical values. Suppose we have the sample size n equals to 12, then the degrees of freedom n minus 1 will be 11. Here is how we can look up in the t-table. The corresponding critical value will be 1.796, which will be negative on the left side and positive on the right side. Let's move on to the example. The average weight of 20 students in a certain school was found to be 165 pounds with a standard deviation of 4.5. Question A. Construct a 95% confidence interval for the population mean. Let's write down what we know. So, we know that the average weight or the sample mean is 165 pounds. The sample size n is 20. The average weight of 20 students was measured in this study. Now, we know that the standard deviation is 4.5. But here's the question. What type of standard deviation are we dealing with? Is this sample standard deviation or is this population standard deviation? Now, typical school is going to have more than 20 students. A typical school might have thousands of students. So, the 20 students in our study represents a small sample of all of the students in the school. Therefore, this is the sample standard deviation, which is S equals to 4.5. Now, when you have a question like this on a test, you need to determine if you need to use a normal distribution or a student's t-distribution to solve it. When you know the population standard deviation, typically you want to use the normal distribution. But we don't have the population standard deviation. We have the sample standard deviation, and that's one indication that we need to use the student's t-distribution to construct the confidence interval. But there's also something else that we need to consider as well, and that is the sample size. When n is equal or greater than 30, then it's a good indication that you want to use the normal distribution. But in this example, n is less than 30. So that tells us that we want to use the student's t-distribution. So those two are good indicators that you should use the student's t-distribution. If you have the sample standard deviation as opposed to the population standard deviation, and if n is less than 30. Now, this is the formula that we will be using. So we know what x bar, n, and s is. In order to construct the confidence interval, we need to determine the value of our t. The degrees of freedom, the one that looks like the letter V, that is equal to n minus 1. N is 20 in this example. So minus 1, it will be 19. Alpha over 2 is going to be 1 minus the confidence level and divided by 2. Now, the confidence level is 95%, but as a decimal, it is 0.95. So the alpha over 2 is 0.025. So in this example, alpha is 0.05, but alpha over 2 is 0.025. So we could determine our t value. So we have 19 degrees of freedom with a one-tail alpha value of 0.025. So at this point, we need to look at the students' t-distribution table. So here we have the students' t-distribution table, and we say that we have 19 degrees of freedom, and the alpha over 2 value is 0.025. So if we find the intersect in row and column, it gives us this number, 2.093, and that is going to be our t value. So let's write here the t value. Now let's follow this expression to construct the confidence interval. Let's replace the x bar with 165. Our t value is 2.093, s is 4.5, and n is 20. Here is how we can solve it. Like that. So this right here is our 95% confidence interval. What does this mean? This means that we're 95% confident that the average weight of all the students in this school is somewhere between 167.106 and 162.894. So that's how you can construct a confidence interval using the students' t-distribution table.